in this lecture, we will discuss the division program. Now, in a microprocessor, there is no direct division instruction. So that's why we have to get the division by using the repetitive subtraction. Now, if I wanted to divide the 9 by 3, then I'll get the quotient as a 3 and remainder as a 0. Now, if I wanted to divide the 9 with the 4, then I will get the quotient 2 and remainder 1. How can we achieve this one means, now here if I'm subtracting the 3 from the 9, then I'll get the answer here 6. Once again I'm subtracting, then I'll get the answer 3. Once again I'm subtracting, then I'll get the answer 0. Now here how many times? 1 time, 2 time, 3 time. How many number of times subtraction is done? That is nothing but what? Quotient. And what left in the accumulator? That is nothing but what? Remainder. Now similarly for 9 minus 4, if we see 9 one time we are subtracting, then our answer is 5. One more time if you subtract, then answer you are getting 1. So 2 times you have subtracted, so that is the quotient, and whatever the answer you got, that is nothing but a remainder. Now this is for the general purpose. Now how to stop means what? This accumulator value continuously we have to compare with the divisor. Now here I have to compare this accumulator value with the divisor. If the accumulator value is lesser than the divisor, then I have to stop the program. And one more method is what? I have to subtract the divisor one more time. Thereby what? Now here I got the 0. If I am subtracting the minus 3, then my result is minus 3 means what? Here carry will set. Now here also, after getting the 1, if I am subtracting one more time, then what I will get? I will get minus 3. Means nothing but what? Carry will set. So whenever we are subtracting the higher value from the lower value, carry will set means what? Every time I am subtracting, I have to check the carry. So when the carry is set means what? So I have now there I have to stop the program. Now here the carry is generated. Now here I have to stop the program. But after stopping, now here if you see 1, 2, 3, 4, 4 times I have subtracted. Now quotient I am getting the 4. But how much I should get? Only 3. Now means what? I have to stop one step before only. But to set the carry, this is mandatory. So after getting the carry, I have to subtract the quotient value one time. And similarly, to get the remainder, I have to add the divisor to the remainder one time, then I'll get the proper remainder. Now here minus 3 I got. One more time if I add the plus 4, then I'll get the remainder 1. So this is like how we have to get the quotient and remainder in the case of division. So that we will try to write the program for this. So only thing is what? Here only 3 times we have to subtract to get the result actually. But in the program, now manually it is, we know that, but how the processor will know? Processor don't know that where to stop. So it has to compare the accumulator value every time. If the accumulator value is lesser than the divisor, then it has to check and stop. This is one method. And another method is what? So every time while subtracting, we have to check the carry. So after getting the 0 also, one more time if you are subtracting, then you will get the carry. Means what? Whenever you are getting the carry, there you have to stop. But already wherever you are getting the carry, there you have subtracted one time extra. That's why what? When while storing the result, you have to decrement one time. Value you have to decrement here. Quotient you have to decrement by 1. Similarly, to get the proper coefficient, one more time you have to add the divisor to the coefficient or accumulator value. Thereby you will get the proper coefficient. Now this is the second method. First method is what? Every time accumulator value you have to check with the divisor. Wherever the divisor value is lesser than the accumulator value, then you can continue. Otherwise you have to stop. This is one method. We are following the second method. That how to do that we will see now. So now for first one, to store the quotient, I'm taking the, now first let me take two values in the memory location. Now 6500 I'm taking once again. So here I'm storing the 09 and 6500 I'm storing the 04. Now I have to store the result 6500 0 1 here, 0 2 here, 0 here. I'm storing the accumulator value is nothing but what? Reminder. And 6503, I'm storing the um, quotient. So that is nothing but what? For that, I have to assign one register. Now for that, I'll take the register B. So now here to store the coefficient, I'm taking the register B that I'm initializing with the 00. And again, now this register I'm initializing, this address location I'm initializing with the HL pair. For that, LXI H comma 6500. So now instead of using the LXI6, now initial pointing the HL register with the memory location, you can use the LDA STA. LDA is for the loading, STA is for the storing. But if you use these number of opcodes, the length of the program will increase. That's why we are going for this one. This is the program using the direct addressing method. This is for the indirect addressing method. Okay, next what we need to do, we have to load the 9 into the accumulator. Now first location value we need to load into the accumulator. For that, what? Move A comma M. Thereby what? In the A value 9 is available now. So now after that, what? HL pair should point to the next, what? This value we have to use it as a we have to subtract this value from this. So that's why what? This value we needed in the next memory location. For that, what? INX H means what? HL pair is pointing to this value. Now that value we have to subtract from the accumulator. For that, what? Sub H sub M we are using. Now sub M means what? Memory location value is subtracted from the accumulator. Now the accumulator value is 5. Now after the subtraction, now one time subtraction is done. So now here we have to increment the, how we will get the quotient, how many times we are subtracting, that value should be counted. That count is done by the B register. Increment B means what? One time subtraction is done. So now the B value is 1. Now here we need to check whether the carry is generated or not generated. If carry is not generated, means what? Here while subtracting, if it is a positive value, then we have to repeat the subtraction. So now here I'm using the loop is a label. This we have to use, means what? If there is no carry, positive difference means what? This is nothing but reminder. If the positive reminder we got, then again we need to do the subtraction. Now it is going here and it do the subtraction once again, and we are getting the 1 in the accumulator. That time, second time subtraction is done. So B value now it is, this time it is a 1. Now this time it is a 2. So now B value is 2 and in the accumulator reminder is there. But now it will check whether the carry is generating or not. But it is a positive difference. Result is a positive, so it will not generate the carry. So that's why what? Once again it will subtract. Once again it will subtract. Thereby you will get the -3. Now here the how many? Now this is the third time it is subtracting. Now value is what? 3. So one time extra it is subtracted. So that is also counted by the this is nothing but a quotient. Now here it is, the value is what? Minus means what? Carry is generated. So if the carry is generated means what? It will come from the loop. So but what is the reminder? Reminder is 1 and quotient is 2. So one more time the subtraction is done extra. That's why what we need to do is, after the subtraction, now here immediately we have to add the M value, means 0.4 with the accumulator. We are adding the 0.4 with the accumulator. Thereby in the accumulator we will get the 1. This is nothing but what? Reminder. Now here we will get the reminder. And also this increment B, it is incremented one more time, one extra. So we need to decrement the B value one time. Thereby what? Here in the B we will get the coefficient, that is nothing but a 2. Now in the reminder we got the 1, and in the coefficient, in the B register coefficient we got the 2. Now these values we need to move into the memory locations. Now here to point to this location we need to increment the INX H. Thereby what? HL pair is pointing to the 6502. Now in this first we need to move the accumulator. it is not mandatory that we have to move the accumulator or we have to move the any one of the value. How you wanted to store? If you wanted to store the remainder first, now these should not be in the higher order. Now coming to the multiplication, accumulator should be first and carry should be next. So here the total value. Now for example, if my result is 123, then the 23 is the lower order and 01 is the higher order. So in the multiplication, you have to store the first location, lower order memory location, you have to store the accumulator. In the higher order, you have to store the carry. But coming to the division, it is not mandatory that you have to store the accumulator first, next you have to store the coefficient. It is not like that. So in the result of how you are storing, if you have a clarity of that, if you wanted to store the coefficient first, then you have to move the coefficient B register to the first, and uh, next you have to move the accumulator like that. Now here I said that in the 6500, I am moving the remainder first means what? So first I have to move the accumulator value. So move M comma A. And after that, one more time, I have to increment the HL pair so that it should point to the next location. Now I have to move the coefficient. Now coefficient is available in which register? Coefficient is there in the register B. So I have to move the register B content to the M. And this is how I have to store. Now after that, what? Halt. Stop the program. Now this is the program for the division. Now I hope you understood. Now this is one way, and another way is what? After the subtraction, every time you have to compare this value with the your division. But that is little complicated. That it will, well, program length will increase. That's why we have used this. So this is the program. The same, we have taken the same location. Now it's the same data. Now it is not mandatory that you have to use the same location and same. You can change any location over here and any location over here. Only thing is what? This location should not clash with this location. That's all. Now how to write the opcode also, I think. Now I have explained that. So now in the while coming to the lab, all of you please you analyze the program and write the opcode and come to the lab for the execution. Now this is about the division.